All right, welcome back, Mrs. Slauson. So now I am covering Roman numeral 8, function operations. So the idea of the function operations is we will either be adding or subtracting or multiplying. We are actually not going to be covering division. So I know that some classes covered this and some didn't, but we're going to be leaving this out because it's not going to be tested. All right, because it comes back in a later chapter. So it's not that it's not important, it's just not, we don't need it for right now, and we're short on time. So I've got these three functions, f of x, this is a quadratic, it's a U shape, a parabola because of the squared. G of x, this is a linear equation, it's a line. And h of x, this is cubic, so this is kind of more of a curvy line. All right, and our job is we're going to be subtracting two of them, multiplying two of them, and multiplying another two, and just checking on their domain. Okay, so let's start there. So we're going to take g of x and subtract f of x. So g of x is this x plus 2. And I'm just going to wrap each function in its own parentheses. Here's the subtraction sign that we're seeing. And then I'm going to put f of x. And when you do add or subtract, adding and subtracting is really picky, so you'll only be able to add or subtract like terms. So the x and the 2x can combine, and the 2 and the 5 can combine. So as far as writing your answer, if this is multiple choice on our test, it will be in standard form. So that means I want the x termed first. So I have basically nothing subtracting the x squared. So this subtraction means you'll be subtracting this term, you'll be subtracting this term, and you'll be subtracting this term. So there's two ways you can do it. One, you can just leave it as subtracting, and when I subtract x squared, it just becomes a negative x squared. And then, so that takes care of this term. I'm going to use a pencil here. And then I want to take in x, and I want to subtract an already subtracting 2x. So you could think of this as x subtracting negative 2x. And when you subtract a negative, that's like adding a positive. I think that's a little tough to remember, and I'll show you a different way to do it, but that becomes 3x. So these are out. And then I'll have 2, and I'll subtract what you should think of as a positive 5, and that gives me a negative 3. If you do want to see if this is correct, again, you could put this into y1, you can put this into y2. When you hit graph or zoom 6 to get a standard window, you should see one shape because these are equivalent to each other. Other than that, let's talk about if you aren't great with subtraction. I don't like subtracting, so what I do is I go to the subtraction that's in between, and I do this process called adding the opposite, and I turn this into addition, so that's the adding, and then I go to each term, and I make it the opposite of what it is. So this is an x squared, I make it a negative x squared. And instead of subtracting 2x, what's the opposite of that? Well, that's adding 2x. And instead of adding 5, what's the opposite of that? Adding negative 5. Your goal is to have it all addition. So now, this becomes this negative x squared just comes down here, and that takes care of that. I'll have a 1x adding a positive 2x, and I get the 3x. And then I'll have the 2 adding with the negative 5, and I get the subtracting 3 or negative 3. So just a suggestion. This time I'm going to take g of x times h of x. So again, always put them in parentheses. Here's g of x, here's h of x, and we are multiplying. This is FOIL. First term, outside terms, inside terms, last terms. But as my class knows it, this is the neighbors meet the neighbors. Since they're so close, this neighbor better like this neighbor. So x goes over first. X and x cubed makes x to the 4th. X with 1 makes a 1x. And now that x has met everybody, now 2 is going to meet everybody, so I get a 2x cubed. And then when 2 meets 1, remember you're multiplying, not adding, that's a 2. And so there's nothing wrong with your answer like this, but if this were multiple choice, you would see it in standard form. So the 4th term, then the 3rd term, then the 1x term, and then the 2. So this is the better way to write it. And again, you want to see if you're right, put this into y1, put this into y2, and you should see one picture. Now I know it did say domain. We'll talk about domain when we're all done with this. So now I'm going to take f of x times h of x. So here's f of x. Again, I'm going to wrap it in parentheses. Here's h of x. And again, they're right next to each other. This is a lot of neighbors meeting neighbors. So this group always goes to this person's house. So first x squared goes to meet everybody. And when you multiply, you add the exponents. So that's x to the 5th. X squared with 1 is an x squared. All right, so x squared has met everybody. Now the minus 2x or negative 2x will go meet everybody. So here and here. So when these meet, I get negative 2x to the 4th power. And I'll just write it next to it. Right now it's not in standard form. I'm not going to worry about that. And then negative 2x meets 1, and I get a negative 2x. So now the last group to go meet everybody is this 5. So 5's going to go meet, and then 5's going to go meet the 1. So 5 with x cubed is, I'm running out of room, so 5x cubed. And when 5 meets 1, remember you're multiplying, that's a 5. So I shouldn't write it stacked like this. So in standard form, I would have x to the 5th first, then my x to the 4th power, then my x to the 3rd power, then my x squared power, and then my minus 2x or plus negative 2x, and then the 5 at the end. All right, let's talk about domain. So I would suggest you look at domain before you do any math. Just set it up and see if you have a domain issue. And right now, the only domain issue we're worrying about in Algebra 2 is, do you have x in a denominator? If you have x in a denominator, remember, you get to pick values for x. So if x is in a denominator, you could pick 0, and you can't divide by 0. So if you have a denominator issue, then you have a domain issue. And I have no denominator here, so I have no domain issue. And I still have no denominator here, so there's no issue. So my domain here is all real numbers, or you could write negative infinity to infinity. On this one, again, do I have a denominator? No. Do I have a denominator even after I cleaned it all up? I sure don't. So same domain issue, all real numbers, or you could do negative infinity to infinity. And that is it for this video.